Hey everybody, welcome to 11.2 Arithmetic Sequences and Series. I want to tell you something about this lesson before we get started, and that is there's two basic formulas I'm going to show you, and a lot of different ways we're going to use the same formulas. So you'll notice on your notes sheet there's lots of different examples. Students usually struggle with these, that's why I put so many on here, but if you understand a specific example, you can fast forward to the next example, but don't skip any. So for example, if you understand it, I did one example, you feel like you understand example 4, skip ahead to example 5, but don't stop the video. Make sure you watch one of each type of example just to make sure that you got it all. Alright, so first of all, in 11.1, we were just talking about sequences in general, and we had all these different sequences in series that were adding, subtracting, doing weird fractions, that kind of thing. Today we're going to specifically be talking about sequences that are adding or subtracting to get the next term, and that's why it's called arithmetic. You can see the word looks very similar to arithmetic. So we're just adding or subtracting to get the next term. Here's the official definition. An arithmetic sequence has consecutive terms. Remember, a term is just each number in the list. So has consecutive terms with a common difference. And that's a fancy way of saying add or subtract to get the next term. So add or subtract to get the next term. And you have to be adding or subtracting the same number every single time. So it's only considered arithmetic if there is a specific number that's being added or subtracted. And that specific number, called the common difference, we're going to denote with the letter D. So if you see D, that means the common difference. Alright, first example, we are just going to determine if each of these are arithmetic or not. So what I want to do is find the difference of each number. So I'm asking myself in my mind, what's being added or subtracted to get the next term? If you look at this one right here, it's adding 4, adding 4. Make sure you test all of them because sometimes they'll switch it up on you, but this one is adding 4 every time. So this one is a yes, and the common difference is 4. We don't have to say plus 4, we just say a 4, a positive 4 if it's adding. We would say a negative 4 if it was subtracting. And just quick comment, if you're someone who can't right in your head figure out that it's plus 4, plus 4, plus 4, you can always do the next term, subtract the previous term. So like term 2, subtract term 1 in order to figure out what the D is. Alright, let's look at part B. So for this one, I notice first it is adding 3, and then it is adding 5, and then it's adding 7. Okay, so there is a pattern, but it's not an arithmetic pattern because it's not adding the same number every single time. So no, not arithmetic. Right now, I'm going to give you the two formulas we're going to use throughout this lesson. The first one is a rule that we can use to find the nth term of the sequence. And this formula can be used in many different ways. But the official name for it is the rule for the nth term. But it's a formula. So that's what they're going to call it in the book, but it's just a formula. Here's my formula. A sub n equals a sub 1 plus, in parentheses, n minus 1, outside the parentheses, times d. And why don't we just write in quick a reminder so you remember what each of these things means. So a sub n is term n, a sub 1 is term 1, n is the term number we're trying to find. Just so you know, this n always matches with this n. So if I'm trying to find term 3, for example, I would put a 3 in for n. And then last but not least, d is the common difference that we just talked about. Now, you are not always going to be given term 1 and term 2. So remember what I said a little earlier? To find d, I could do term 2 subtract term 1. I'm going to give you a more general kind of formula that you could use, and that is you could take any term, subtract the previous term, but if it's not term 2 and term 1, on bottom I'm going to subtract by the term numbers. So on top, a sub m, subtract a sub n, and on bottom, m minus n, and then the term m always has to come before term n. But that way I can use this formula even if I don't know two terms that are right in a row, which is really convenient. And I'll say more about this in a little bit. We'll kind of use that formula throughout the lesson. Okay, so that's kind of a side note. The other official formula we're going to use today is the sum formula. And the sum formula looks like this. It says S sub n, that means the sum of the first n terms. The sum of the first n terms, that is equal to n times, in parentheses, a1 plus an on top of a fraction, on bottom of a fraction, 2. So it's the number of terms times first term plus term n divided by 2. And again, you'll get very familiar with these formulas as we go along here. A major component of this lesson is finding formulas for different sequences. So there's actually 3 different ways that they're going to give you information and that we will need to use that information in order to find a formula. So we're going to start with the easiest one with example 2. It says write a rule for the nth terms. So again, when it says write a rule for the nth term, they just mean create a formula. But the reason I keep mentioning this is on tests and quizzes and in the book, that's how it's going to officially say it. Write a rule for the nth term. But really they just mean create a formula. Alright, anyways, if you look at my formula up here, I need to know A1 and I need to know D in order to figure out my rule. So here's what we'll do. If I look at my sequence, A1 is 50, that's the first term. And D is, well, if it's written out like this, you can actually just find D just by kind of in your head, really. Do you see how it's subtracting 6 each time? So D is -6. I didn't even have to use the formula to find D that time. And then here's what we do. I'm taking my rule for my nth term. I'm going to plug in A1. N stays N, because that's how it's going to create a formula for me here. And then I plug in D. Now, sometimes if you're on an MCA test or something like that, they may leave it in this format, and sometimes they want it in simplified format. So I'm going to show you how to do both. To simplify it, we just rearrange. So this is a parentheses next to something multiplied to it, so I'm going to distribute that off. So now I've got 50 plus -6n, and then -6 times -1 is +6. Last but not least, combine like terms, and we always write the n first. So -6n plus 56. So that is the simplified form of the rule. That is the one I'm going to be looking for when we're taking tests and quizzes. Just, again, standardized tests like the MCA or maybe ACT sometimes have this and sometimes have this. Unsimplified. Okay, then they want me to find term 12. So I just created a formula. If I want to find term 12, that means that n is equal to 12. And when I am actually finding a number, a term number, I plug in n, and then I just can go ahead and solve. And now it makes it a very easy problem once I have the formula created. So -72 plus 56, a sub 12 equals -16. So this is the easiest type of thing you're going to see today. So I'm not going to do another example. I'm just going to have you pause right now and try part B on your own right away. So go ahead and pause the video, try part B. When you unpause, I will have the answer revealed. All right, there's our answer to example 2B. Go ahead and check your work there. And just a quick comment, I don't know if you were thinking this or not, but if you look at the formulas that we just created, if I just replace this with y and this with x, it looks just like a y equals mx plus b formula. And that's how it's supposed to look, actually. So if I graphed an arithmetic sequence, it'll always create a straight line if I graphed it. We're not going to have to do that for this class, but you might in tests in ACT, MCA, get an equation like that, and you got to graph it. It should create a straight line for an arithmetic sequence. All right, look at example 3. So this is the next type of thing we're going to have to do. We're still doing the same, we have the same objective, that is to create a rule for the nth term. So again, I'm trying to create a formula for this sequence. Now we are given less information. So here's what I'm given now. I am given a term, and I'm given D. In order to create my formula, remember, we need A1. So my first step here this time is to find A1. And we can actually use our formula to get there. Let me show you what I mean. If I know a term number, I can leave A1 as a variable, but I know term 13. So here's what I'm going to do. I'm going to make n be 13 this time. And you always put the actual number, n is 13, here, and you put the term number, so the term number is 30, term 13 is 30, here. So I'm going to make the nth term be term 13 right now. So again, I put the term number, the actual term goes here, term n, and then the number of the term, so it's term 13, goes here in for n. That's a little confusing. Anyways, I know A1 is just going to stay A1 because that's what I'm trying to find, and then I was given the fact that D is 3/2. Alright, so now I just set up an equation I can use to solve for A1. 13 minus 1 is 12. 12 times 3/2 is 18. And as really, once you know how to set it up, it's easy. It's just the setup is really confusing. Okay, so 12 equals term 1. Now that I have term 1, and I have D that was given to me, now I can create my rule. So, to create your rule, or your formula, you always want to plug in A1, and you want to plug in D, and then we'll simplify. So again, first step, distribute. So right now I have A sub n equals 12 plus 3/2 n minus 3/2. Combine like terms, so 3/2 n plus 10.5, or you could have it in fraction form too. Either one is fine. Alright, I'm going to do one more, and then I've got 2 on the back side of this sheet for you to try on your own. So again, I need to find A1. And again, this is what is confusing. I am going to have this time, I am given term 20. So what that means is n is 20, and that means term n is actually term 20, which is actually negative 111. So where an was before, I'm going to put in negative 111. A1 stays A1, again, that's what I'm trying to find. Where I had n, I'm going to put in 20, because I'm using term 20 this time as A sub n. So that's the thing. A sub n could be any term you want it to be, and it's going to change every single time just depending on the information you're given. D is negative 6. So that's my setup to find term 1. Let's go through and solve. So I got negative 111 equals A1. 20 minus 1 is 19. 19 times negative 6 is negative 114. So add 114 to both sides. And 3 equals term 1. Then again, once you found A1, step 2 is to create my formula, or to create my rule, we call it. I am going to plug in term 1. Term 1 is 3. I'm going to plug in my D, and remember, whenever you're creating a rule, you want to leave n as n. That way you can use whatever formula you create to find any term you want to. So I got 3 plus negative 6n plus 6, combine like terms, and I got negative 6n plus 9. Pause if you need to understand that question, and then I'm also going to right now pause the video and try C and D on your own if you feel like you need extra help. If not, you can fast forward to example 4, but when you unpause, I will have the answers for C and D on the back page showing. Alright, there's our answers to C and D. So again, if you want to ask me about any of these when we get to class tomorrow, let me know. Let's move on to example 4. Now this is the most tricky type of trying to create a rule, and again, our objective is still the same. Example 2, example 3, and example 4. My goal is to write a formula for a sequence. Now, though, we are going to be given 2 terms. So if you look at what I've got here, I'm given term 6 is 10, term 21 is 55. So we actually do not know D, we do not know term 1. we're going to have to find both of them. The easiest way to do this is to find D first, and you can use the formula I showed you, which is term M subtract term N over M minus N. Check this out. This time I am given term 21 and term 6. So the numbers of the term go on bottom here, 21 minus 6, and the actual numbers go on top. So term 21 is 55 and term 6 is 10. And notice you always put the whatever one is later in the sequence first. It doesn't matter which one's a greater number, it's which one is later in the sequence. So term 21 would come later in the list than term 6. Alright, solve that. I get 45 over 15. Okay, D is 3. Once I know what D is, now I can find A1, and this part of finding A1 is the same thing we did for example 3. So I have D now, same exact thing we did for example 3 to find term 1. So you could use either term 6 or term 21. Either way, you should get the same correct answer. So I'm going to use term 6 just because it looks like smaller numbers this time. So again, I'm going to use this formula to find term 1. I leave that blank as term 1. I'm going to use term 6. So I'm going to say that N is 6. So N is 6 right here. I'm going to use term 6 for term N, and then we just found D to be 3. So again, see how this is the same thing we just did earlier? 6 minus 1 is 5. 5 times 3 is 15. So I got 10 equals A1 plus 15. Subtract 15 from both sides, and A1 equals negative 5. And now my third step is the same thing again that I did for example 3. Now I'm just going to write my formula, or write my rule, it's called, my rule for the nth term. Alright, so when I write my rule for my nth term, I plug in A1, I leave N as N, and I plug in D. Then I distribute D, so that would be 3n minus 3 for that part. And then finally, I combine like terms. So term n this time equals 3n minus 8. I'm going to do one more of those type, and then I'm going to let you try 2 of them on your own. So again, there's actually only one extra step on this example versus example 3, and that is we have to find D. So that will be my first step here, is to find D. This time, I've got term 30 and term 5. So M subtract N, remember on bottom you put the term number, on top you put the actual value of the term. So on bottom I've got 30 minus 5, on top I've got 110 minus 10. And you know what, that is 4. So D is 4. Step 2, I'm going to find A1, and again I could use either term 5 or term 30. I'm going to use term 5 just because it looks like it's a smaller number. I don't know, so maybe it'll be easier. So N is 5 this time. Okay, so I am going to say, I'm going to use term 10 is going to be 10, N is 5, and D is 4. 5 minus 1 is 4. Okay, 10 equals A1 plus 16. Subtract 6, and A1 is negative 6. And then let's find our formula, or our rule. Plug in term 1. Plug in D. Distribute. Negative 6 plus 4n minus 4, and combine like terms. So that is equal to 4n minus 10. Hopefully that kind of made sense. That is definitely something you're going to want to study, because for whatever reason, students always forget how to do that when we get to our tests and quizzes. So you might want to make a note right now. Study. Okay, I'm going to let you try C and D on your own, and when you unpause the video, I will have the answer showing. Good luck with it. Alright, once again, after you have checked your answers, go ahead and go to the next sheet of paper and star any that you want to ask me tomorrow, and you can ask me some questions if needed. All right, so now we're going to get to that other formula I showed you right at the beginning of the lesson. I wanted us to put it on the front page so then it's handy when you pull out your 11-2 notes, you'll have the sum formula right away. But now for the first time we're going to use it in this lesson. So this is the same thing you wrote on the front page. We'll just rewrite the formula so it's more handy to us right now. But remember how I said yesterday, a sequence is a list of numbers with commas in between. A series is a list of numbers with plus signs in between, and for a series we actually add them together. So we're going to be using series right now, so we're going to actually add some terms together. And just like we did with the other formula, our objective is the same for every example 5, example 6, example 7. Our goal is to add terms together, but the notation is going to be a little different every single time. So once again, if you get the hang of it, move on to the next example. Fast forward, but don't skip any examples. Make sure you watch at least one of each type so you know what's going on here. All right, so if I look at this formula, in order to use the formula, I need n, I need a1, and I need a term n. So if you look at this formula, just so you know, these are the 3 things we need to find every time to plug it into the formula. It's just going to be a little different how I find each of those 3 things. All right, let's look at example 5 then. So first off the bat, this one, they actually made it kind of obvious what n is, because they said find the sum of the first 30 terms. So however many terms we're adding together is n, so n is 30. They also made it very obvious to find term 1, because I know the first term in the sequence just by looking at it. Term 1 is 4. What I don't know is what term n is, and because n is 30, I need to actually find term 30. So in order to use my sum formula, I need to find term 30, and this is where we are going to actually use the other formula we learned earlier. So we're going to use my find any term formula, and it's crazy because we're using the same formula in so many different ways. Now, if I'm going to find term 30, n is 30, and then I plug in my other information. So I know term 1 already, that's 4. And we don't yet know what d is, so we need to find d. This time it's obvious because I can just do from 4 to 7 is 3. But sometimes you might need to use that formula. And then notice this time the missing piece or the variable is term 30 because that's what I'm trying to find. So this time it actually makes it a little easier because I can just type that all into my calculator if I wanted to. 30 minus 1 is 29 times 3 is 87. So term 30 is 91. Okay, again, I need those 3 pieces of information in order to use my sum formula. So the only reason I did that is to find term 30. Now I'm actually ready to find my formula, or use my formula. I say s sub 30 because I'm finding term 30, and then I'm going to plug everything else in. So here I go. So n is 30. Term 1 is 4. Term 30 is 91. There we are. Comment. Make sure you put that in parentheses if you're going to type that all into your calculator. But after you get that, you should be able to just type it all in. Try it just to make sure you can do your calculator entry correctly. You should be ending up with 1,425. I'm going to pause the video. Go ahead and try B, and when you're ready, unpause it. All right, go ahead and check your answer for part B. And then, quick comment, this is the first time in this lesson, actually, I think, we've ended up with a sequence that actually was decreasing every time. So because it's going down, D is negative. So it's decreasing by 2 each time, so we say D is negative 2. All right, again, write down any questions you have. We're going to move on to example 6. Woo! All right, so here's example 6. Now my goal is the same. I want to find the sum. Finding all my information is different. I still need to find n. I need to find term 1. I need to find term n. That's still the same, but the way I find it is different. Okay, finding term what number n is easy. Whatever is on top here, as long as this starts at 1, whatever's on top is n. So n is 45 right now. And then we actually, just by looking at this, we don't know what term 1 is or term n. And by the way, because n is 45, I want to find term 45 this time for term n. So you know what though? This is kind of cool because they gave us the formula rule. This is the formula rule. In order to figure out what term 1 is, for example, just put in a 1 into the rule. And to find out what term 45 is, just plug in a 45 into the rule. And you can use your calculator to solve them. So this one ends up being 15. And this one ends up being 191. So I have my 3 pieces of information. Pause and look through that and make sure that you understand it, or rewind if needed. But again, I found my 3 pieces of information. It was just a different process of how to find it. All right, let's go on. So now I need to find my sum. I'm going to plug in n. I'm plugging in a1 and I'm plugging in a45. And then I am using my calculator, and I get a sum of 45. The first 45 terms is 4,635. All right, I am going to do another one. Let's look at B. So again, I'm finding my 3 pieces of information. This time, the number on top is a 32. So n is 32. To find term 1, and then term n is going to be term 32 this time, since n is 32. I'm going to take my formula rule and I'm going to plug in. To find term 1, plug in a 1. To find term 32, plug in a 32. Just be careful with your negatives, especially when you type this in. I end up with term 1 is negative 12. Term 32 is negative 74. Now I'm going to just plug it into my sum formula. And I end up with the sum of the first 32 terms is negative 1,376. All right, go ahead and pause and watch part C. Or, try part C. And when you're ready, unpause it. All right, check your answer to part C. And when you are ready, unpause the video and move on to example 7. All right, now we're going to do something different. Instead of finding a sum, I'm actually going to try to take my series I'm given, or sequence, and write it in summation notation. So just a quick review. Summation notation has a little sigma. Right here, I put my formula rule. I have some variable, I, n, or whatever, representing what I use in my formula, and then I'm going to go from here to something, depends on how many terms there are. So let's say I'm going to use n this time. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 terms, so I will put a 9 on top. And by the way, that is the only thing that's new. Right now, finding what goes here, which is the rule, is the exact same thing we did in examples 2, 3, and 4. So again, I am doing arithmetic. In order to write my rule, I plug in term 1, which look at our list. Term 1 is 1. And then I'm going to plug in something for D. Look at our list again. It looks like it's adding 2 each time. Adding 2 would be a positive 2. I end up with 1 plus 2n minus 2, or 2n minus 1. So I just plug that in right here, and I have just created summation notation. There we go. All right, the rest of these will be done in class. I will right now pause the video and do example B and then unpause. So if you want to try that one on your own on the back, you can. And I'll talk to you again soon. Thanks for listening.